Okay, I am now sharing my screen. You can see my screen, right? Right. Okay, good morning, everybody. My apologies. I'm back to office, so today, I need to travel, and there's unexpected traffic this morning. So my apologies. I was late for 5 minutes. All right. So in today's class will be like the officially last class of the semester. And in today's class, I'm not going to teach you anything at all. We are really done with our syllabus. We're done with digital logics design, topic 1 to topic 8. We've done all those topics in the past 10 to 12 weeks, I suppose. And in today's class, I will talk about the last element of this course. So as you guys might have noticed, this course we do not have final exams, right? And in place of that final exam, we are going to have this final project, okay? Final class project. So in this class project, it is going to be in place of your final exam. In final exams, you have 40% weightage, right? So similarly, this final project also has got 40% weightage. All right, so in today's class, what I'm going to do is I'm going to explain to you what this project is all about. I'm going to brief it to you. How do you do this project? And then I'm also going to go through some examples. What are the good examples and what are bad examples of project that I've got from my last semester's students so that you guys have an idea on how to do well on this project. All right, so let's jump into it. This is my PowerPoint slide. So let's get to it. So this is the question for this final class project. Okay, so this question says we need to design a synchronous counter. Okay, bear in mind this is synchronous counter. Okay, that counts the sequence of your student ID. Okay, so for example, if your student ID is EE014537, just a random number I pick, then the counter will be doing this sequence. It's going to count from 0, 1, 4, 5, 3, 7, 9. And then it repeats itself again. Okay, so this repetition will go in a loop and it will never end. So you can use any flip-flop to realize your design. And yeah, feel free to use SR flip-flop, JK, T, or D flip-flop for this design. And after you've done that, prove that your counter is working by using a simulator. So you can use Circuitverse. You can use Logically. You can use if you have your Digital Logic Lab simulation program, you can even use that as well. Okay, but I would recommend you guys using Circuitverse because it's so easy to use and so easy to see. All right, that is the question. Okay, so the main question is that, and however, I've also offered 2 other bonus questions. So these 2 bonus questions, they are not compulsory, but if you guys are able to do this, then it's bonus mark to your project. Okay, so the first bonus is after you've got your design, you want to upgrade your design so that it can do the reverse counting. So instead of 0, 1, 4, 5, 3, 7, 9, it counts the reverse. It counts from 9, 7, 3, 5, 4. Okay, you get the idea, right? So you can go forward, you can count forward, and you can count backward as well. So it's forward and reverse counting. Okay, so you can upgrade your design to do that. That is the first bonus. And the second bonus is to design the counter with other type of flip-flop. Okay, so in the main question here, you have designed, let's say you've designed your counter using SR flip-flop, right? Let's suppose that. So in this bonus question 2, redesign your counter using another type of flip-flop other than SR flip-flop. You can use T flip-flop, you can use D and I, right? You get the idea. So that's the second bonus. So bonus questions are not compulsory. You can attempt them. You can also choose not to do them. Okay, if you choose not to do them, there will not be any deduction of the mark. But this bonus 1 and bonus 2 question, they are designed for me to see those who wants and to those who take the initiative to get extra from this project. So, right. So if you take the initiative, this is your reward. Your reward is bonus 1 and bonus 2 question. If you don't want to take the initiative, fine. I'm not going to judge you. I'm not going to say anything. Nothing will be, nothing will be different. It's just you get your final class project, and you can even get full marks if you don't attempt bonus 1 and 2 questions, right? Okay, so let's take a look at this. I'm going to walk you through this design process. So if you've gone through I posted one video on not yesterday, day before yesterday, after our class. I posted one video. I think that video really succinctly summarizes all the processes, step-by-step process on what you need to do to get a counter. Okay, so by the way, this video is down here. It's by Neso Academy. I think it's one of the best reference out there, one of the best tutorial video guides out there for you to learn digital logic. So go check that video out. So this is what I took from the video. Actually, I've learned a lot as well by watching those videos. So this design process, there's like 5 designs, 5 steps over here. First, you need to decide number of flip-flop. So how do you decide number of flip-flop? Like, watch the video, then you know how to decide how many flip-flops. And then from there, you get the excitation table out. So what is an excitation table? Again, we've covered this in class, but if you watch the video again, it will briefly elaborate what's excitation table all about. And after the excitation table, you've got something else we call the state diagram. Right? State diagram is just a drawing of some bubble-like diagram. So if you watch the video, you would see that the state diagram is something like a flow chart. Okay, so from one box, from one bubble, from one circle, flows to another one, flows to another one. So those are called state diagrams. So we didn't really cover state diagrams in this class, but I don't have to cover this to let you know that there is a state diagram. So by now, I really hope that everyone already got the idea that knowledge is out there. So it doesn't mean that we don't talk about it in class. It doesn't exist, right? So knowledge is out there. All you got to do is just take 5 minutes of your time, search about what is state diagram, and boom, that's how you learn about state diagram. You just know what's state diagram, right? So once you get the state diagram and excitation table, you got to do the K-map, and from that K-map, you get the final logic diagram. So study this video very, very carefully. Go through it step by step. Go through the example that the video is making, and after that, after you've understood how to make a basic counter, then attempt this final exam question by making a counter with your student ID. Okay, so that is what you're supposed to do for this final project. Okay, let's talk about what you need to submit. Okay, so submission consists of these 2 items actually. First item is report. So first item is the report, and this report should show all the workings that you take to solve this final exam questions, right? So I will post a template for this report later after we end this session. I'll post that template, and all you got to do is like midterm project, use the template and just fill in question 1, question 2, question 3, and then just put some elaboration on what is this all about. Okay, what is question 1 all about? What are you supposed to do, and what are you showing me in that working? Just some kind of elaboration. Okay, that's the report part. And the report will be in soft copy, and I will grade that report with your soft copy. Okay, secondly, this project also requires that you submit a tutorial video. Okay, this tutorial video is very similar to what you did in a midterm, but this time the timing is only 15 minutes. Okay, in the midterm, I allow you some kind of a very generous time, 30 minutes or more. But in this submission, only 15 minutes, strictly only 15 minutes. This is the constraint that I want you to work on. Okay, so this will be very useful, I think, when you're an engineer someday. This is the limited resource that you have. You only have 15 minutes. So take the best part of your project and present that in that 15 minutes. Okay, and I will evaluate your video as well alongside with your report. Okay, so I will be opening your video and I will see your report. Does that tally or not? See, that is what I will do, and that's how I will evaluate your report. And lastly, a demonstration is what I want to see in the video. Okay, so don't just put your demonstration inside the soft copy. So the soft copy is not to say it's not a demonstration. It is a demonstration, yes, but all you can do in the soft copy is that you take a screenshot and then it's just there. It's not moving. It's not, it's not alive. So what I want to see is that you demonstrate your product. Think about it as your product. Demonstrate that in your video. Show it to me. Okay, this is working. So how do you know it's working? What's the proof that it's working? That is what I want to see in a video, okay? A demonstration of your counter, a working counter. All right, so these are the steps similar to the previous slide. Okay, any question up to this point? Is that clear? Everything is clear? You know what to do, you know what to submit, and we'll talk about deadline after this. Anyone? So everything's clear, right? Okay, so if everything is clear, then I want to talk about tips on how to do well. Okay, so these are some of the tips that you can take it from here. You can take it from me. How to do well. These are based on what I observed last semester from students who did well. And I also observed students who didn't do well, and I also try to tell you, okay, what you do, what are examples to do well, and what are some examples that makes your work not so good. All right, let's talk about this. Okay, first tip on how to do well is you need to show step-by-step working, and workings are clear in the report. So in your report, show it to me everything, every single step that you have taken to solve this. Okay, don't assume anything. Don't assume that I know anything. Yeah, you can assume that I'm just a 5-year-old kid. I don't know anything, and you just put everything you can in that report that helps you to solve the problem. Okay, don't assume that I know what's K-map. Don't assume that I know what's a truth table. Don't assume I know what is a JK flip-flop. Okay, so everything that you use, every single element, put it in your report, please. This is what I want to see, and this just demonstrates to me how well you understand. Okay, all right, that's the first one. Step-by-step workings are clear. Okay, so I would highly encourage you guys to learn how to use, how to make a proper report. The proper report means it's nicely typed out, not using your own handwriting, not like hand-drawn diagrams. Type everything out, do it nicely and neatly. That is a report. Okay, so going forward, when you're working in an industry, nobody's going to take like handwritten reports anymore nowadays. Okay, if you submit handwritten reports, it just shows that you're not very professional in your job. Even though you are good, I get it. Even though you're good at your job, even though you're professional, even though you're competent, but if you just give me a handwritten report, and that handwriting, especially if the handwriting is not so neat, is very hard to read, then that just gives me a bad image of you. Okay, I'm not talking about myself only, but to any other employers out there also. If you just give them, oh, they want a report, and you just give them, okay, just a scribbling on some papers, and you submit it to them, then you are giving the impression that you're not putting a lot of effort in your report, even though you are doing that, but you're giving out that kind of impression. Okay, so this is especially true if your handwriting is not very tidy. Type it out, everything. That just tells me you're putting effort in writing this report. Okay, that is this is my tip to do well. Obviously, if you think that your handwriting is well, okay, please go ahead. This is not a compulsory requirement in my class. I don't want to make it a compulsory requirement. I just want to educate you. This is the right direction to go. Whether you want to take it right now, you want to start doing it right now. I applaud you for that. I encourage you to do it. If you don't do it right now, at some point in your life in the future, you still got to do it, right? So I'm trying to train you guys to get used to this. Get used to writing reports. Get used to doing things in soft copy. Right? Okay, coming back over here, step-by-step workings are clear in the report. Okay, if you draw something, make sure you draw it out nicely. If you want to draw a handwritten diagram, if you want to draw it on a paper, scan it nicely. Make sure it is like there's no shadows or everything. So make it as professional as you can. Okay, treat this as a $1 million project. That is how to do well. All right, that's number one. Number two, okay, you got to prove it to me as much as possible that the work is yours. Okay, so I get it. It's online class. I don't see you, you don't see me. Okay, so that's why when I'm evaluating your work, okay, you got to think of it this way. My default mindset is that you're just copying from one another person. That is my default thinking for everyone who submits the project, because I don't see you guys in class and I don't know how are you doing actually. So that is my default thinking. So what you got to do in this project is that you got to change my mind. You got to make sure that I change my, after I look through your soft copy, I change my mind. Oh, okay, this person, wow, he did so much in this project. This guy must not be copied from anywhere else. So, okay, you get the idea? Prove it to me as much as possible that the work is your own. Okay, so you got to make me believe that you're not copying from anywhere else. Okay, I'm not saying that you cannot refer. Go and refer the website, the entire web, the entire internet is yours, but you got to make me think that you're not just taking things blindly. Okay, not just taking things from this website. Okay, just paste everything here, and you got to by the end of your report, I should have changed my mind. If I don't change my mind, and I have so many reasons to suspect that you're just copying, then you're not going to get good mark. Okay, so that's why show everything in a report, show every single step that you took to solve the problem. Then I will change my mind. Okay, get it? All right, so that is a second one. Prove to me as much as possible that you are doing it yourself with this project. You can get help, no problem. Get help from your friends, get help from the internet, get help from anyone else, but you got to show it to me that you understand. That is how to do well in this project. And this one is especially true in the video. So if you get help from your friend and you don't understand it, and you find that you have a hard time to explain it in the video. All right. So I would love to see how you explain things in the video and show it to me in your soft copy. That is how you can convince me that you're not just copying, you're not just blindly taking from any other sources and just putting in your report. Okay. So prove it to me as much as possible. The work is yours. That's the second point. Third point, I noticed that those who do well, those who did well last semester, the audio and video is very clear. Okay, clear as in like what I'm speaking to you right now. There's no background noise, there's no like buzzing sound. It's just my voice and it is clear. There's no other distraction in the video. Okay, audio and video is clear, not too loud. The volume is not too low. It's just nice. If you go to refer to any YouTube video, you can listen to how the person is speaking. Yeah, that is good enough. Okay, proper explanation as well. So try to explain things as detailed as you can, but bear in mind you have 15 minutes. Okay, explain things. What are the steps that you took to solve the problem within the 15 minutes? And I really hope that you guys will make full use of the time. So you have 15 minutes, right? Make full use of 15 minutes. Okay, right. Last semester, there were students who submit a video that's 2 minutes. Okay, so I don't know what you can explain in 2 minutes. This is like a big project. You can explain it in 2 minutes. Well done. If you can use 2 minutes and convince me that this work is yours and everything is like done step by step, well done. I applaud you. You can be a very good project manager, project engineer in the future. All right. But in this project, it's not compulsory that you need to make full use of 15 minutes. You can use 10 minutes, you can 12 minutes, 30 minutes, 40 minutes, but make full use of that. If you think 10 minutes is enough for you to explain things, everything with proper explanation, then go ahead with it. All right. But I would highly encourage you guys to make full use, because 15 minutes is the opportunity that you have. Think about it, that you have 15 minutes to convince a client. You have 15 minutes to sell a product to your future client. So you want to use that full 15 minutes, right? You don't want to use like 5 minutes and then, okay, just throw away 10 minutes. 15 minutes, they are your opportunity to show your project, opportunity to convince me that this work is working, this work is genuinely yours. Use that 15 minutes. These are your opportunity. Don't waste it. Okay, make full use of the time. All right, and lastly, okay, link is accessible. This is very common last semester. Like every semester, I get that students submit me a video, then the link, I cannot access it. All right, so make sure that the link can be accessed before you click on the submit button. So if you have Google Chrome, what you can do is you can try Google Chrome in an incognito mode. I'm not sure if you know what is incognito mode. Okay, so let me show you guys here. So this is my Google Chrome, as you can see over here. If you go over here, can you see this? New incognito window, click on that. Okay, so this incognito window is going to simulate a stranger, somebody else that's accessing your link. So paste your link over here, paste your YouTube link over here. And if you can access this YouTube link in incognito mode, that means I can access it. Okay, so do try it out. Do make sure your link is accessible before you submit them to me. Okay, because once you submit, I will not like, I will just grade your video as I can access it. So I have no, I don't have the privilege to go to every single one of them and making sure, oh, everyone's link is working. Okay, so you got to do that favor for me. Make sure you do your part well. Make sure your video is accessible, and I can I can be freely using my time to just grade your grade your project without having to make sure that your link is accessible. And if it's not accessible, what do I do? Do I message you, and then do I wait for your reply? And you know, things can get very complicated because like there's so many of you in the class. Make sure your link is accessible. Test your link with incognito mode, or you can use any other browser, or you can ask your friend to access your video actually if you want. Right? Make sure that is done. It's a very little thing, but you know, you've done your project really well, but then if the link is not accessible, well, oh my God, that's just like you've bought your flight ticket, but you didn't take the flight. It's just so wasteful, right? So make sure these little things, do it well, guys. Don't let these small things ruin your entire project. All right. So, okay, lastly is show that project can work in a demonstration. So a lot of you in your midterm, like you show me the project can work in the soft copy, but some of you didn't really show me that your project can work in demonstration. So I don't make this compulsory in this project, but if you can convince me and show me a live demonstration, that will be like a wow factor. Okay, so like think about it. Like if you have a product, if you want to sell something to your boss or to your client or to anyone, and all you can do is just show the video, okay, show something, is show the product through a picture or through a video, but you don't have the real thing in front of you. Like people will still be skeptical, right? So it will be different if you can take the real product and show it right in front of them. That is how demonstration will make a big difference. Okay, especially true with this assignment where things are changing, things are moving, okay, things are blinking. You want to demonstrate your project in that video so that I can know that, oh, okay, this project is working, and then you're not trying to, you know, you're not trying to just beat around the bush and convince me. Show it to me. This is working, and then like I have no other reason to think that this project is like not working. Okay, prove it to me as much as possible. All right, so those are tips to do well. Okay, any question on the tips? Anyone? Okay, no question. Okay, so after this, I'm going to show you guys some good example and some bad example. Okay, let's just look at this one. Okay, so this is a submission that I got last semester. Obviously, I'll keep the name, a student's name, anonymous. So in the report, this is what I get in the report. The report has got long, it's supposed to be a many pages report, right? So I expect maybe 5 pages or more in the report. But in the report, this is the only thing I get. This is the only thing I get in the report. Just some scribbling. I don't even know what is this in the beginning, and I have to like, oh, okay, this is like a flip flop. Okay, thank you very much. Like, I don't even know how to grade. There's no like, there's no steps. There's no nothing. There's no question even. Like, it's just this drawing in the report. Can you imagine that? So this is an example of a bad report submission. Okay, not only is the report incomplete, there's no indication that this is question 1 or this is step 1, step 2. There's nothing of that, but it's just one scribbling, and that this scribbling is not even great. Okay, so do not submit this kind of report. Do not submit this kind of drawing. This drawing is not great. Try to draw as much as possible using software, a computer software. You can draw it using PowerPoint if you like. You can draw it using Circuitverse if you like, but you can draw it on paper even if you like. But please make it nicer than this. This is like absolute minimum, right? Okay, so make it nicer than this. No one is going to be convinced that this is a good product by looking at this drawing. Okay, so that is one example of a bad report. Okay, let me show you what is an example of a good report. So this is an example of a good report. So take a look at this. So this is the question. Take a look at that. The student wrote down the question. Okay, this is the question. So this is a student ID. Okay, therefore the sequence is blah, 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 blah. Okay, and then to achieve this, these are the explanation that the students give in this report. It's very well done. And that is this. Here is the state diagram. So here's how the state diagram looks like, and then take a look at this. This is handwritten, right? So this state diagram is drawn by hand. But what's the difference? What's the difference between this and this? They're both handwritten. This is much more tidy is neat. So those are all, even though they are handwritten, they are carefully scanned and they are carefully put inside. Take a look at how much thought the student put into this report. Put everything in a box showing that this is a diagram. Even got a caption over here. Figure 1 shows that. Well done. Right? This is a very good example of how to write a report. Okay, and Karnaugh map. Okay, take a look at this. Karnaugh map. So using the K-map method. Okay, this is some elaboration by the student. Okay, and then how to do this K-map. Okay, this is, and again, another figure, and take a look at how much thought the student put inside here to make it easy for me to see. Okay, this is a different color being used over here. Okay, so that is how much thought the student has put into solving this. So this has already convinced me. I'm sold. But just look at this and say, okay, I'm sold. I'm convinced by that. Okay, you actually did this. Take a look at this effort that this student is putting. I don't think I need to go through every single detail anymore in this report. Okay, that is how you convince me that you are doing this by yourself, not just doing a sloppy job, copy this, pasting this here, and not putting any effort. Okay, so effort matters to me in this project. This is a good example of a report. Okay, all right. Any question up to this point? This is my last slide, by the way. Let me just show you something else. Let me show you. Yep. Okay, I want to show you some of the best videos that I got last semester. Let me. I've got a lot of good videos last semester. I just don't know which one to show you as an example. Okay, some of them actually made it. Some of them actually took down. Okay, let's just go with this one. Okay, so can you guys see my video actually? Okay, can you guys hear the audio actually? I'm playing some. Can you guys hear the audio from the video?
No, sir, we can't hear anything.
Cannot hear the audio, right? Okay, let me do some adjustments over here. Device. What about right
now? We still can't hear, sir.
You cannot hear? Okay, never mind. I think how do I share the audio? Center mode, blah blah blah. Okay, yeah, I think I got it. Include computer sound. Okay, I suppose now you can.
2021. So I am from University Tenaga Nasional.
Can you hear the audio from the video?
Yeah, now it's clear, sir.
Okay, so I'm going to show you one sample on how to do well. Okay, this is an example video. Okay, on one of the best video actually that I got last semester. So take a look. First thing, take a look at the duration of the video. 15 minutes, right? This student is fully making use of the opportunity that she has. 15 minutes fully used. Okay, plus minus. I have a kind of little bit of tolerance here. 15 minutes, 39 seconds. It's fine. Okay, but not 20 minutes, but not 25 minutes. Okay, 15 minutes. Stick to it as close as possible. Okay, so firstly, I like the timing over here. The timing tells me that okay, she is making full use of this opportunity. That's number one. Okay, number two, take a look at this video, which video shows her face presenting. Okay, that just tells me that okay, she is doing this presentation by herself. She's not asking anyone else to do the presentation on her behalf. So that gives me confidence. Okay, she is really doing this project herself. Okay, so that's how you change my mind. Okay, otherwise I would have 1,000 reasons to think that are you the one presenting in this video, right? I don't even know how you look like. All right. So this is how you change my mind. Show you in this video, and take a look at the background. Take a look at this video. It's so nicely done. It's so neat, and I think it's professional to a certain extent also. Of course, like I don't want to go into the detail. Okay, this this is a little bit like cartoonish. Okay, this is fine. This is not a graphics design class. I'm not going to evaluate you based on what kind of graphics that you use, but make sure it's neat, make sure it's clean, make sure it's presentable. Okay, that is how I will evaluate your video. So let's take a look at that.
My name is Nur Syairah Sami'an binti Abdullah from Section 2 Digital Logic Design.
Okay, good introduction by yourself, short and brief. Don't give a long summary of what you did and what your hobbies are. No, short, sweet introduction, and then get into the project. Okay?
So this is
right. Next, what she does is she covers the question. Okay, mention the question. Okay, this is the question. What you're supposed to design. I'm supposed to design this kind of counter. Okay, the counter is supposed to go through my ID. This is my ID. Okay, then that gives me an idea already. Oh, okay, because everyone's ID is different, right? You cannot expect me to remember your ID. Show it to me. Show it to me over here so that I can have an easy time grading your project. So I have a very pleasant time grading the students' project because it's so easy on me. Okay, so make it as easy as possible for me to grade your project. So if I find it very hard, okay, what are you trying to do? If I'm trying to guess over here, then you're already losing point on the way. So make it so that I don't have to guess. What are you trying to say over here? What are you trying to do over here? Okay, if I don't have to guess, then you've won half of the battle, right? So this student did a good job. Okay.
Our question. The question is 00.
Right. Introduction. So for the explanation, she's going to elaborate on what's the game plan, right? So this is what she's going to do. Okay. She's going to count this 0, 1, 0, 7, 0, 5. Okay. Elaborate a little bit on what are you going to do? How is the game plan like? This is the original one. Okay.
So one, we will have a few problems in pipe.
So there is a few problems in this project because you notice that there is some kind of repetition over here, 0, 1, and then you go back to 0 again. So if you're designing a counter, you'll find that this is a problem actually. This video from the YouTube video that I showed you just now, it could not handle a repetition of digits. So this is how this student solved it. So I really hope that you guys can go out and look for some solution. How to solve repetition in your digits. All right. So this is what the student did, and this is what she did. And after that, let me just forward it. Okay, and then she decides the number of flip-flop. Okay, so take a look. She did this JK flip-flop. This is what she decided to use, and then we need 4 flip-flop. Okay.
And we need 4 ZK flip-flops to complete the synchronous counter because our sequence is a 4-bit binary number.
So that is what the student is trying to do. Okay, how many flip-flop? 4 flip-flop, and then like how she's going to do it. Then she proceeds. Okay, this is the next one. This is the state diagram. How she's doing the state diagram. Here. Okay.
We go.
Okay. How you go through step by step. What is in this state diagram? What does this represent? What does this tell you about your counter? Okay, that's how she explains on the state diagram. Okay, and this is the state table. Okay, again, you can. Everyone's state table is going to be different, so it'll be pointless if I just talk about this state table, right? Right. Okay, I'm just going to go forward. Okay, this is how the K-map looks like, and she's going to explain how she does the K-map.
Output of K3, the group, and the Boolean equation.
Okay, so explain as much as possible on how you get the group. How you get the equation for this K-map, and what show me as much detail as possible in this video.
X and 1 from the output.
Okay. And finally, she got this working. This is the flip-flop. Okay, flip-flop 4, 3, 2, 1, and those are the logic diagram for her ID. And that logic diagram is connected to a display. Okay, take a look over here.
Put distribution pipe.
Okay, simulation.
So segment block we get from this construction of some logic gates. So come back here. When I enable the clock, the number will go from 0, 1, 0, 7, 5, 7, and 1. And it will repeat from 0 again.
Okay. a look at that. This is demonstration. If you can show me this live demonstration, I'm sold, you guys. I'm sold. Take my money. You know, you get the idea. Okay. So show me a live demonstration, and that will completely change how I think about your project. So as much as possible, make use of this. This Circuitverse is one example. You can use other similar software for live demonstration, right? So let's take a look at next. Okay, then she attempts the bonus question. Bonus 1. Okay, upgrade the design. Okay, and she's gonna explain what she did in bonus 1, blah blah blah. Okay, and then she's gonna, okay, this bonus 2. Okay, she's gonna design again using another kind of flip-flop. Okay, so this is what a good video will look like. So in the end, so I really hope that if you, I'm not saying that you guys should copy this video exactly. No, there's not one way to do a video. There's many ways to do a video. Even if you don't put like this fancy diagram, it can still be a good video. As I said, I'm not gonna pick on your design. I'm not gonna pick on your font over here. Oh, is it nice looking font? Is it a nice looking graphics? I'm not gonna do that. This is not a graphics design class. This is digital logic class. I'm going to evaluate based on your content. Okay, but if you put your content and you put a nice graphic with your content, does that help your content stand out? If yes, then that is a good graphic. If your graphic is going to just distract me away from your content, then that is not a good graphic. Okay, I am going to focus on your content, not the graphics. All right, so this is example of a good video. So I don't think I want to show example of a bad video. A bad video has 1 minute, 2 minute explanation and just show me, oh, this is the final outcome. So that's a bad video. So don't do that. Okay. All right, that is example of good and bad report submission, and I've shown you how does a good video look like. All right, that will be the end of this project page. If you have any questions, do let me know. And from this point on, I would say that we will have no more official class during official hours. Okay, official hours means your class time. It's on Tuesday 3 to 5 and Thursday 8 to 10. So we do not have class anymore going forward from this week, from next week onward. But during this time is the time I will open the door for help, for consultation. Okay, so I will be still guiding you through this project, but it will be only for those who reach out to me. So if you guys need any help in the project, I am here to help you out. I'm not here to just give you a project and I forget about it. No, I'm not trying to do that. I am trying to help you complete this project. So during your class time, Tuesday 3 to 5 and Thursday 8 to 10, I will be available to help you guys. Right? So drop me a message one day before and tell me that you need help with the project, and then we can talk about it during that specific time. Okay? So do let me know if you need any kind of help, and do let me know in advance. And next week onwards, yeah, we don't have class, but the time is open for consultation and help. So do take note of that. Okay, so one last slide before we end our class. So this will be like the last class of the semester. So this is one quote that I really like from one of my favorite scientists. His name is Richard Feynman. So this quote goes like this: "Don't let college to get in the way of your education." So what does it mean? Don't let college to get in the way of your education. So this is something extra that I wish you guys can take from my class. As I said in the beginning, I don't want my class to just be about digital logics, because after the end of this semester, all these digital logic things, they are going to fade away. But it is things like this that will stick in your mind. And I really hope that you guys will take this nugget from my class. Right? So what does it mean? Don't let college to get in the way of your education. So we used to think that if you go to college, then you are educated. College equals education. But guys, make no mistake, this is not the case. There are a lot of people who are in college, in university, have a PhD, but they're not educated. Don't make this mistake of thinking you're in digital logic class, therefore you're educated. You're in a university, therefore you're educated. It's two different things, guys. You can have a PhD, you can be a professor, but yet you can also be uneducated. So I am seeing this already in my surroundings. Right? There's a lot of people around me who are like super duper smart. You know, they're professors, they're this and that, but yet their mindset is not educated. Okay, they cannot think clearly. They don't know how to learn new things. Okay, they're just in the education system, and they're just doing what they are told to do. Okay, don't let that happen to you guys. So don't let college get in the way of your education. As I said, education is out there. The way to get education is to explore, to build, to make things. Okay, so how do you do that? You got to learn. How do you learn? A lot of resources nowadays. Okay, the exercises we've done in the class throughout this semester, I really hope that you guys already learned a little bit on how to learn. Google, YouTube, they are your friends. So those are education. So if you learn how to do that, I think you can say to a certain degree that you are educated in some sense. Educated is not about knowing how to do K-map. Educated is not knowing how to do JK flip-flop, knowing how to design this. That is not what educated means. Educated is learning how to learn, learning how to grow, learning how to adapt. That is what it means to be educated. Okay, so I really hope that you guys don't allow this class to be a barrier for you to become educated. You guys don't let university to become a stumbling block for you to be educated. So it is my job. It's my job as an educator to let you guys know that this is the case. I wish someone told me that when I was in digital logic class, when I was in my university years, I wish someone told me that going to university does not mean educated, right? So I am telling you guys, this is my responsibility to let you guys know this is different. Going to college is not does not equal to being educated. All right, and don't let college stop you from becoming an educated person. Don't let college stop you from fulfilling your fullest potential. Right. So that is officially the end of my of this semester's class, and today is like last class of the semester. We do not have any more class online meetings after this, and for that I would like to end this session by saying thank you, everyone. Thank you for enrolling in this class. Thank you for staying with me until the end of the semester. Even though I don't know how you guys look like, even though I don't know physically, I don't see you guys, but I have faith and I believe that you guys are following well. Okay, so I really wish you all the best in your journey going forward. Even after you graduate this class, you can take the things that you learn from this class and carry on into your next class, into your next phase of your life even. So I really hope and really wish the best for you guys. And also I would like to apologize on my part. And I realize that I'm just a human being, and I'm not trained to teach online as well. And I realize that sometimes there can be hiccups in my class, and that sometimes there can be problems also in my teaching. And sometimes the way I explain things, it might not suit how you see things. It might not suit your understanding. So I apologize for all of that shortcomings. If you can let me know, if you're kind enough, you let me know how can I improve so that next semester I can improve on that and people can benefit from with your feedback. So if you have any, do let me know. All right. If you're afraid that this feedback will affect your grade, don't worry. You can send me your feedback after everything is over, everything is out, everything's ended. You can send me a feedback after that. You can do that too, or you can send me now. I assure you that the feedback will not affect any of your grades. And yep, I wish you all the best. And I think next semester onwards, if you're in college, if you're in uni, if you see me around, just say hi. I don't know how you look like, but you know how I look like. So you can just say hi. I was in your digital logic class. Oh, then I will remember that. Yep, it's this class. Okay. So I wish you all the best. Take care, and I will see you in your video presentation. All the best, guys. Take care.
Thank you,
All right. See you.